Hello. Today's objective is that you will find surface area of 3D shapes using discovery and formula. Sometimes you use formula, but we're really going to talk about what it's like to take apart a three-dimensional shape like this. So what we have here is a parallel solid or a triangular prism. So you notice that it's got a triangle on the bottom and a triangle on top, and its lateral sides are made of rectangles. Um, there's different ways that you can think about this, but if you think about taking this apart, there's that right triangle. Sorry, my drawing's not going to be great. And that's got a 6, 8, and 10. And then if you folded this out, there would be a rectangle sticking off this side, a rectangle sticking off that side, and then a rectangle sticking off the hypotenuse. And because this length right here is 5, that means each of these rectangles would have a that second side of 5. And then don't forget, at the bottom, there's also that last triangle there. So it kind of doesn't matter where it goes. You've just got one more triangle sticking off. And it's the same as the first one. Again, sorry for my terrible drawing. This right here is called a net. And it's when you take a 3D shape and you draw its surface area shapes all flat connected to each other. Once you have this, you can kind of approach the surface area problem from scratch. So I'm going to do this in pieces. First thing I'm going to notice is that this rectangle, or I'm sorry, this triangle is repeated. So I'm going to say 2 of the same triangles. And if they were different, I wouldn't put them together, but these ones are, of course. We also have 3 rectangles, and those are all different from each other. So I'm going to label this like rectangle 1, 2, and 3. So I'm going to say plus rectangle 1, plus rectangle 2, plus rectangle 3. All of these things added together, these 2 triangles, which are the same, plus these 3 different rectangles, are different, together make the surface area. So we're now able to actually start doing our calculations. Surface area is equal to 2 times the area of that triangle, which is 1/2 base times height, and the base and the height are determined with the right angle, so the base and the height are 6 and 8. So this is 2 of those triangles, plus the first rectangle is 6 by 5. So this is 6 by 5. Plus the second rectangle is 8 by 5. Plus the third rectangle is 10 by 5. And if you can get here, you're going to get this right, because everything after this is just arithmetic. But just as just to recap this, what we're looking at right now is 2 triangles plus a rectangle plus a rectangle plus another rectangle together make the surface area of this 3D shape. So let's finish off calculating this. 2 times 1/2 times 6 times 8 is 48. Plus 6 times 5 is 30. Plus 8 times 5 is 40, plus 10 times 5 is 50. So let's see what we have here, 50, 90, 120, 168. So our surface area of this shape is 168, and our measurement is centimeters squared. Area is always measured in units squared. We're now going to go on to the second example, which is a cylinder. Cylinders, we're going to start with the net again. Cylinders are a little, maybe not what you would expect. Obviously, the top and the bottom are circles. So this circle right here, I'm going to start by drawing right there. And you'll see that other circle in a second. But the lateral side of the cylinder, imagine if you actually like snipped that right there and unrolled it, what you would have is a rectangle. And that rectangle would be connected to the circle on one side, and then the circle on the bottom would also be there as well. So hopefully my wonderful drawing here makes it look like a circle and a rectangle that goes across. Let's put in some measurements. So we've got a radius, in this case, of 5. I'm not going to draw it down there as well. You know it's the same one. And that's, of course, because the diameter was 10. The height of the rectangle is 12. And the width of the rectangle, this right here, well, that width was what I'm drawing right here. That was this, right? So that was the circumference of the circle. So the width of this rectangle is 2 times pi times the radius of the circle, which is 5. I'm going to simplify that right now to 10 pi, although you could leave it like that if you wanted. So what we have here is 2 circles plus 1 rectangle, and now we're going to be able to get started. Again, because our circles are the same, I'm combining them, otherwise I'd have to calculate them separately. So our surface area is 2 times the area of each of those circles, so pi times 5 squared, plus the area of the rectangle, which would be 12 times 10 pi. And now we'll simplify it, and we're basically almost done here. So 5 squared is 25 times 2 is 50, so we have 50 pi. Plus 12 times 10 is 120 pi. So our final answer here, when we add these together, 50 pi plus 120 pi is 170 pi centimeters squared. So to generally recap, we either drew the net or you picture what it would look like in its individual shapes. You write down what those shapes are. You write down their area formula with the numbers plugged in, and then you calculate. So our objective was finding surface area of 3D shapes using discovery and formula.